As the name implies, the Basin Range is a province made up of long, narrow, north to south trending mountains, alternating with broad valleys. Steens Mountain is the highest range in the province at 9,670 feet, followed by Warner Peak at 8,065 feet and Hart Mountain at 7,724 feet. The basins vary in size, as do the lakes filling the lowest portions. Klamath Lake is the longest at 50 miles, followed by Summer Lake at 20 miles. Both lakes are about 10 miles wide. Almost all of the rivers except the Klamath River have reduced watersheds that empty to the interior. The largest within the province is the Chihuahuan River that drains 620 square miles. The largest originating in the province is the Klamath River that flows 257 miles through Oregon and Northern California, emptying into the Pacific Ocean. Unlike most rivers, the Klamath begins in the high desert and flows towards the mountains, then carving its way through the rugged Cascade Range and Klamath Mountains before reaching the ocean. John Fremont explored and named the province in the 1840s, describing the topography and recognizing that it drained internally. However, the name Basin Range was coined by the famous geomorphologist G.K. Gilbert. Israel Russell, third from the left, a disciple of G.K. Gilbert, did most of the initial geologic survey of the area. Russell was followed by Ira Allison, who began work in the Basin Range in 1936. He was with Oregon State University for 62 years. The Basin and Range across south-central Oregon is only a small portion of a vast region that covers parts of Utah, Nevada, California, New Mexico, and Mexico, encompassing an area of 300,000 square miles. The Oregon Basin Range is bordered on the west by the Cascade Mountains, on the north by the high lava plains, and to the east by the Owyhee uplands. Exposures of underlying terrain rocks are limited to the fringes of the Basin Range in Oregon, and it is necessary to step over the border to Nevada to find pre-Cenozoic rocks. In the Pueblo and Trout Creek Mountains on the Oregon-Nevada border, metamorphic rocks and granite intrusions have been assigned to the late Paleozoic era to Jurassic period. These exposures suggest that terrain rocks, felsic rocks, may form the basement in Oregon underlying Cenozoic rocks. Today, the north-northwest motion of the Pacific Plate at more than 2 inches per year with respect to the North American Plate can be linked to extension and right lateral strike-slip faulting of the mainland. Accommodating that motion, the California Shear Zone, a broad band of strike-slip faults east of the Sierra Nevada mountains, may project into central Nevada and Oregon, where it is known as the Walker Lane Zone. The most profound event in the Basin Range is the east-west stretching or extension of the crust. With extension, the crust was pulled apart and thinned until it began to fail. Visible in this image are slickened sides and striae characteristic of movement along a fault. The resultant normal faults provided routes for mineral-laden hydrothermal fluids to reach the surface and lavas to reach the surface as volcanic eruptions. Beginning 12 million years ago, northwest trending strike-slip faults and north-northeast normal faults modified the topography of the province. The dextral strike-slip faults were active as late as 7 to 8 million years ago. The McLaughlin, the Eugene Denio, and the Brothers Fault Zones are enormous structural features comprised of a network of overlapping faults having 150 feet of displacement and about a mile of separation between them. The shear fault zones parallel the Olympic Wallowa lineament. Extensional tectonics produced north-northeast faults that give the province its character of elongated tilted blocks, horse, and valleys, grabens, that widen northward. With extreme extension and thinning of the crust, Central Oregon may have expanded to twice its original width. North-northeast fault blocks dated at 6 million years cut the older northwest fault belts. The younger faults, which define the topographic character of the province, are several miles apart and show displacements of several thousand feet. The ranges are elongated and are open at the north end. The long-lived Steens Mountain fault has been active over the last 10 million years. Summarizing the timing and progression of faulting, the oldest is the Steens Mountain in the east, Albert Rim Fault at 8.7 million years, and then the younger Cascade Arc at 5 million years. Severely carved by Pleistocene glaciation, the upthrown block of the Steens Mountain escarpment display the classic features of glacial erosion. In this view towards the north along Albert Rim, the faulty blocks are clearly delineated. To date, the most recent movement along the north-northeast trending faults, vertical displacement and fresh fault scarps of Pleistocene lake sediments were recorded at various central Oregon lakes, including Lake Albert, dark blue in the image. With the exception of the 1968 Adele earthquake, which was generated by motion along the Warner Valley Fault, the last activity along Albert Rim occurred about 2,000 years ago. The oldest eruptions from the Coleman Hill and Rabbit Hills complex along Albert Rim dated 29.3 to 21.7 million years ago. These are bimodal, rhyolitic, and basaltic lavas that formed much of the late Oligocene to early Miocene landscape of the Basin Range. Volcanism on the eastern margin of the Oregon Basin Range began in Middle Miocene with flood basalts from source vents near Steens Mountain. Originating from what was thought to be a huge shield volcano, the huge flow formed a subprovince of the Columbia Plateau. An expanding plume of magma accounts for the age progression of the Betty's Butte, Tucker Hill, and Yamsay Mountain volcanics. Age progression is characterized by bimodal volcanism with a west-younging progression in ages of silicic volcanic rocks. The age progression is in a direction near the back azimuth of plate motion and is widely interpreted as the trace of a sheared-off mantle plume head as it made contact with the thicker Precambrian cratonic lithosphere. The age progression of the decapitated and reformed plume head or cap crudely mirrors the northeast younging trend of the Yellowstone Snake River Plain volcanic system, both trends originating in a common region along the axis of the Middle Miocene flood basalt volcanism of the Steens and Columbia River basalts. This image illustrates the progression of ages of rhyolitic silicic lavas and calderas from McDermott caldera to Newberry and Yellowstone calderas. Numbers are ages in millions of years. Both tracks originated at the McDermott caldera on the Oregon-Nevada border, with the youngest volcano on the northwest trending track of the Plume Head ending at Newberry caldera, and the youngest volcano on the continuing northeast trending hotspot at the Yellowstone caldera. Devil's Garden Volcanic Field is a volcanic field located southeast of Newberry Caldera in Oregon. The lava field consists of several flows of Ahoy lava that erupted from fissure vents in the northeast part of the Devil's Garden. The main vent on the north end of the fissures fed two large gutter tube systems. Several small vents to the south produce the blowouts, which are two large spatter cones, several small spatter cones, and flows. Several older hills and higher areas were completely surrounded by the flows to form kipukas. The distal ends of the flows show excellent examples of inflated lava. The flows cover an area of 45 square miles, 117 square kilometers. Devil's Garden is most likely between 50,000 and 10,000 years old. It is certainly older than the formation of Crater Lake, as ash from the eruption of Mount Mazama overlays the Devil's Garden lava flows. The Pleistocene began about 2 million years ago with increased precipitation and low temperatures, alpine glaciers, and pluvial high rainfall lakes. During the Ice Age, 9 pluvial lakes occupied central Oregon. The largest of these was Lake Modoc, covering about 1,000 square miles. Dependent on precipitation, ephemeral lakes changed dramatically with variations in climate. Today, during an interglacial warm phase, the water bodies are shrinking. Fossil discoveries have included at least 23 mammal species, 74 bird species, 7 fish species, and 11 mollusk species. Some of the large mammal fossils found at the site include Columbia mammoths, ground sloths, dire wolves, giant beavers, prehistoric bison, 3 species of camels, several horse species, peccary, and an extinct bear. Bird fossils include flamingos, pelicans, swans, and large eagle species. Fish fossils include tui chub and several salmon species. Reaching 4 meters or 13 feet at the shoulders and 10 tons or 20,000 pounds in weight, the Columbian mammoth was one of the largest species of mammoth. It had long curved tusks and 4 molars, which were replaced 6 times during the lifetime of an individual. Paramegalodon measured about 3 meters or 9.8 feet in height and weighed as much as 1,000 to 1,089 kilograms. This is a low sun angle photograph of Lake Alvord. Old terraces and wave-cut benches clearly mark former water levels and shorelines of the lakes. Exploration of the Basin Range Pleistocene lakes with boreholes or ground-penetrating radar yields a clearer picture of benches, deltas, spits, channels, and other geomorphic features. The identification and mapping of paleo shorelines at Lake Alvord confirms stages of fluctuating water levels and climates. Cooling during the Pleistocene fostered the onset of extensive ice masses on the Steens, the only range in the Basin Range province that experienced glaciation. The ridgeline in this image has been thoroughly dissected by erosion. Where glaciers cut into the east rim of the mountain, the crest migrated westward where ice left only thin-walled canyons. On the west face, where gradients are less, glaciers moved slowly, carving U-shaped valleys. Holocene earthquakes in this province appear to be moderate in magnitude and average once every 10 years. Seismic activity is associated with clusters of young north-northeast trending faults projecting from the eastern California shear zone. Earthquake studies utilizing aerial photographs, field mapping, and published studies have predicted a 10% chance of a seismic event of magnitude 7.0 taking place in central Oregon every 1,000 years. Holocene slides are not common in this province, and most are debris flows caused by summer downpours. However, geomorphic evidence obtained from the Punch Bowl slide indicate that the Bennett Flat and Foster Creek landslides occurred from 900,000 to 17,000 years ago. These were single events, while the Punch Bowl slide occurred in multiple episodes, most recently 10,000 years ago. About 200 tons of uranium ore were extracted from volcanic rocks at sites northwest of Lakeview. This mine was closed in 1965. Contaminated ponds and radioactive stockpiles pose hazards to residents, recreational users, wildlife, surface streams, and groundwater. In 2005, the EPA began a remedial action program capping the most polluted soils, neutralizing the acidity of the ponds, and recontouring. However, a cleanup plan for the plume of contaminated groundwater that is spreading through a shallow regional aquifer remains to be implemented. Mercury was also extracted at the same mine previous to uranium mining. Now, as January 8, 2012, Australian-owned Oregon Energy LLC hopes to mine 18 million pounds of yellowcake uranium from the southeastern Oregon high desert 10 miles west of McDermott near the Oregon-Nevada boundary. Along the eastern Steens Mountain escarpment, hot springs in the Alvord Basin contain sodium bicarbonate, sodium chloride, along with concentrations of fluoride, arsenic, and boron compounds. Borax salts were mined from the lake from an 800-foot wide pool that discharges water at 97 degrees Fahrenheit. Between 1897 and 1907, the 20 Mule Team Borax Company produced 1,700 tons annually. Borax is no longer mined. The Oregon State gem is the heliote or sunstone. It is a calcium-rich, clear oligoclase feldspar that vary in color from orange, yellow, red, green, and blue. The color depends on the amount of hematite in the stone. Another gemstone found in the Basin Range of Oregon are blue and fire opals. Opals are a hydrated form of quartz derived primarily from volcanic ash, which crystallizes at low temperatures. The annual income from both gemstones is around 1.5 million. Because of its high temperature gradient, thin crust, and numerous faults, the Great Basin is distinguished for its thermal resources. Water is heated by two processes. One, crustal extension and thinning brings heated rock in contact with near-surface water, where the water emerges as hot springs through faults and fractures. And two, hydrothermal fluids comes into contact with magma at depth before the circulating water reaches the surface. The Oregon Basin Range is semi-arid with precipitation ranging from less than 8 inches annually in the lowlands to greater than 30 inches per year in the highlands. Water is supplied by snowmelt, rainfall, or springs. Most of it either trickles into playas or is lost to evaporation. Almost all streams in the province have no outlet to the sea, but rather drain into the basin. The exception is the Klamath River. Smaller creeks are mainly intermittent, and rivers with headwaters on the ridge tops are perennial. Their flows are augmented by groundwater stored in tertiary volcanic and sedimentary rocks. The most reliable aquifers are within interbeds between fractured basalt flows that are recharged from uplands. Historically, surface water supplied domestic and irrigation needs, but groundwater pumping due to reclamation project has increased 50% over the last 10 years or so, bringing a 15-foot decline in water levels. Basin and range topography is a mixture of precipitous escarpments, gently sloping meadows, and flat lake beds. Modoc Rim, Winter Rim, Albert Rim, and the Hartenstein Mountains, the most prominent, breaks the province into basins. Steens Mountain rises more than a mile above the desert floor. Steens Mountain is a large fault block, a horst. The western side of the mountain is a gentle slope that grades into Catlow Valley, while the eastern face drops abruptly into the Alvord Desert. Hole in the Ground is a large Mayor volcanic explosion crater in the Fort Rock Basin of Lake County, Central Oregon, northeast of Crater Lake, near Oregon Route 31. It is about 1 mile, 1,600 meters across, a little longer north-south and east-west. Its floor is about 150 meters or 490 feet below the surrounding ground level, and has a rim that rises 35 to 65 meters, 110 to 210 feet above, the highest point on the east side. The crater formed during the late Pleistocene between 13,500 and 18,000 years ago, at which time the Fort Rock Basin was a lake and the location was near the shore. Basaltic magma intruded near the surface, flashed groundwater to steam, which blew out overlying rock and soil, along with some juvenile material. As material slid into the hole formed, it closed the vent and the process repeated, eventually forming the huge hole. Blocks as large as 26 feet or 8 meters in size were flung as far as 2.3 miles or 3.7 kilometers from the crater. One can still find striations and erratics on Steens Mountain. Many erratics were carried by glacial ice from snow-covered heights to be dropped some distance from where they were plucked from the mountain. Looking north into Kiger Gorge, the flat bottom and U-shape of a glaciated valley are unmistakable, as are the distinct flows of the Steens basalt holding up the walls of the gorge. Along the rim on the right is an arete which separated glaciers in adjacent valleys. Fort Rock was created when basalt magma rose to the surface and encountered the wet muds of a lake bottom. Powered by a jet of steam, molten basalt was blown into the air, creating a fountain of hot lava particles and frothy ash. The pieces and blobs of hot lava and ash rained down around the vent and formed a saucer-shaped ring of lapilli tuff and volcanic ash sitting like an island in the lake waters. The wave-cut terraces on the south side of the ring marked former lake levels of this now dry lake bed. Southerly winds, which are still predominant in this region, apparently drove waves against the south side of the ring, eroding the soft ash layers, breaching it and creating a large opening on the south side. The lakes were home to Homo sapiens as well as other mammals. These petroglyphs are found at Petroglyph Point on Lake Tule, a remnant of Lake Modoc. Several levels of petroglyphs at Petroglyph Point reflect the rise and fall of lake water over time as artists paddled out to carve these images. Ancient Lake Modoc, which once reached 75 miles in length, has receded to the present-day disconnected and lower Klamath Lakes and Tule Lakes of California. Pluvial Lake Chihuahuan, whose remnants are Summer Lake, Lake Albert, and the Chihuahuan Marshes, was originally almost 375 feet deep. On either side of Steens Mountain, the mud floors of Alvord and Guano basins have been broken into gigantic fissures with polygonal patterns, ranging in size from 50 to 100 feet long and up to 15 feet deep. On Guano Lake, some of the polygons are up to 100 feet across, making them the largest in North America. The fissures were caused by dropping water levels and drying of the thick clays in the lake bottom. So I leave you with this image of the Mudcracks in Lake Alvord, but they are not of the large polygons. I was unable to find photographs of them. Thank you for listening to this lecture on the Basin Range Physiographic Province of Oregon.